students, Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will talk about a new lesson. In the previous session we talked about the third lesson of Unit 1. Today we will talk about the first lesson in Unit 2, which is called mirrors. Before talking about mirrors, we have studied before that we see object due to the light reflection. What is meant by light reflection? Light reflection is the rebounding or bouncing or returning back of light ray in the same direction when meeting a reflecting surface. What's meant by that? When the light ray fall on a plane mirror or any reflecting surface, it returned back again. That is called light reflection. To study light reflection, we need to know some concepts that related to it. Firstly, incident ray. What is meant by incident ray? Incident ray is the light ray that fall on the reflecting surface. Let's see together. This is the incident ray. الray اللي falling on the reflecting surface اللي هو in this case هو كان الplane mirror. This is called incident light ray. The second definition is the reflected ray. What is meant by reflected ray? It is the light ray bounces from the reflecting surface. أو light ray اللي عملت reflection أو returning back when it falls when the light ray fall on the reflecting surface. The reflected light ray أو light ray اللي عملت reflection أو bouncing هي اللي بنسميها reflected ray. This is the reflected ray. And there is a perpendicular line makes a normal angle with the plane mirror or the reflecting surface, which is called the normal line. احنا في الماث اخدنا انه الانجل بتكون دايما between two lines او two rays. Between the normal line اللي هو perpendicular line and the incident ray there is an angle which is called angle of incidence. يبقى what's meant by angle of incidence? It is the angle between incident ray and normal, and also between the reflected ray and the normal there is an angle called angle of reflection. يبقى احنا كده we talk about four definitions: incident ray, reflected ray, angle of incidence, and angle of reflection. Now, let's talk about the laws of light reflection. We have two laws for light reflection. The first one said that angle of incidence equal the angle of reflection, while the second said that incident light ray, reflected ray, and the normal to the reflecting surface lie in one plane perpendicular to the reflecting surface. Let's see a small video to explain those two laws.
Our topic for today is laws of reflection. Good job. What happened to our light? No idea. I have an idea. Really?
Huh?
Consider this ray of light which strikes a mirror. This ray of light is called the incident ray. The point at which the incident ray strikes the mirror is called the point of incidence.
Huh?
Let's go up. Draw a line perpendicular to the mirror through the point of incidence. This line is called normal. The angle which the incident ray makes with the normal is called the angle of incidence. It's still not working. My idea is not over yet. When the incident ray strikes the mirror, it will bounce off the mirror. The ray which bounces off is called the reflected ray. The angle which the reflected ray makes with the normal is called angle of reflection. Let us learn the two laws of reflection. The angle of incidence is always equal to the angle of reflection. If the angle of incidence is 30 degrees, then the angle of reflection will also be 30 degrees. Remember that these angles are always measured from the normal, not from the mirror. The incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane.
As we can see in those two laws in the video, the first one, the angle of incidence must equal the angle of reflection. Whatever the value of the angle of incidence, the angle of reflection will be the same. The second law, it said that incident light ray, reflected light ray, and the normal lie in one plane. This plane is perpendicular to the reflecting surface. What are the types of mirrors? We have two types. The first type is called plane mirror. The second one is called spherical mirror. We will talk about each one of them with all the details. Firstly, we will talk about the plane mirror. And now let's talk about the first type of mirrors, which is plane mirror. What is meant by plane mirror? It's a piece of glass painted from behind with a thin layer of silver metal. It means that we bring a piece of glass and one of its sides we painted it with silver metal. Why silver metal؟ هنعمل painting بالsilver metal لسببين. Firstly, to make the plane mirror shiny. Second reason, to make it a reflecting surface, so you can see the image in it. Let's see the properties of an image which formed by a plane mirror. When you look at the mirror, what will you see? Firstly, the image is upright. Upright means not upside down. 2. Reversed, it means laterally inverted. Laterally inverted, it means the right hand of the person, when he looks at the mirror, the image of him, his right hand, the image will be the left hand. Property number 3, equal in size to the object. You see your image at the mirror equal to your size, not taller or not shorter. Number 4, it's virtual, it means can't be received on a screen. Number 5, the distance between the object and the mirror equal the distance between image and the mirror, and we will explain it in the video. Number 6, the line connected between object and the image perpendicular to the mirror. Let's see a video to explain the properties more.
From our previous video, we know what virtual images are. Virtual image is the image which appears to be formed at the position behind the mirror. But in reality, it isn't formed there, as no light rays reach behind the mirror. Now the image formed by a plane mirror has some properties or characteristics. One of the characteristics is what we've already seen. The image formed by a plane mirror is virtual, or in other words, it's not a real image. The other characteristic of an image formed by a plane mirror is that the image formed is always erect or upright. For instance, if you look at your image in the mirror, you will see that it's straight or erect. But will it always be erect? Not necessarily. Maybe it's inverted. Well, we can think of inverted as opposite of upright. Yes, an inverted image means an upside down image. Concave mirrors can form inverted images. The plane mirror never forms an inverted image. The third characteristic of an image formed by a plane mirror is that it's of the same size as the object is on the other side of the mirror. For example, if the height of this person is 4 feet, then the image's height will also be 4 feet. And if I bring the plane surface of the circular coin near the plane mirror, then both the coin as well as its image will have the same diameter. The image formed by a plane mirror is not upside down, but it's laterally inverted. What do I mean by this? When we raise our left hand, the image in the mirror raises its right hand. Our left is the image's right, and similarly our right is the image's left. So an image follows left-right reversal. So we say that an image formed by a plane mirror is laterally inverted. Now we come to our last point. Finally, the image formed is at the same distance from the mirror as the object is. You can verify this observation yourself. All you need is a chessboard and any chess piece, say a king. Keep the plane mirror at the edge of the board as shown. Look at the position of the king as well as its image. Are they both at the same distance from the mirror? Well, you can count the number of squares in front of each. For the object, there are 7 squares in front and the same for its image as well. You can move this king anywhere on the chessboard and find out if its image is always at the same distance from the mirror as the king is. So these were the characteristics of the images formed by a plane mirror. Let's quickly review them. First, the image formed by a plane mirror is virtual and not real. Second, the image formed is always erect or upright. Third, the size of the image formed is the same as the size of the object placed on the other side of the mirror. And lastly, the image formed is at the same distance from the mirror as the object is. In the next video, we will see what ray diagrams for plane mirror images are and how to draw them.
After seeing the video, let's revise the properties of the image formed by a plane mirror. Upright, it means not upside down. Number 2, reversed or laterally inverted. Reversed, it means laterally inverted. مع كلمة reversed يعني معكوسة مش مقلوبة. Reversed هنا معناها إنه when you raise your right hand, your image in the mirror will raise its left hand. Number 3, equal in size to the object. So the length of your body is the same length of your image in the mirror. Virtual, it means not real or can't be received on a screen. Number 5, the distance between the object and the mirror equals the distance between the image and the mirror. If the distance between your body and the mirror 3 meters, so the distance between the image and the mirror is 3 meters too. And finally, when we draw a line between my body and my image at the mirror, that line will be perpendicular to the mirror. And now we can answer a question. Most of us seen an ambulance car, and when he looks at it, we see the word ambulance is written laterally inverted, but when you look at the front mirror of the car, you see it written correctly. Why it is written laterally inverted? To be seen laterally correct by the plane mirror of the car in front of the ambulance car. Why we need to see the word ambulance correctly written in our mirror? To clear the road for it to go to a patient or to deliver this patient to the hospital. By the end of this question, we end our discussion about the first type of mirrors, which is plane mirror, and we will explain the other type, which is called spherical mirror. And now, let's talk about the second type of mirrors, which is the spherical mirror. What is meant by spherical mirror? Spherical mirror, it is a mirror that its reflecting surface is apart from a hollow sphere. What are the types of a spherical mirror? Concave mirror, which is called converging mirror, and the second type is convex or diverging mirror. Let's see what are the shapes of convex and concave mirror, and then we will read the definitions. As we said that the spherical mirror, it is a mirror that its reflecting surface is a part of a hollow sphere. It means that as we have a sphere and the cut a part of it, and this cutted part is the mirror. If the reflecting surface is the inner side, so it is a concave mirror. So the concave mirror, its reflecting surface is the inner side or the inner surface of the sphere. and if the reflecting surface is the outer surface, so it is a convex or diverging mirror. Those short lines means that this surface is not the reflecting surface, and the other surface is the reflecting surface. Here in the concave, the short lines are drawn in the outer surface, so the inner surface is the reflecting surface. But here in the convex mirror, those short lines are drawn in the inner surface, so the outer surface is the reflecting surface. Let's see some definitions related to the mirrors. Firstly, the center of curvature. As we said in the previous slide, that the mirror is a part of a sphere, and the sphere has a center. So the center of curvature, it is the center of the sphere that the mirror is a part of it. 2. Radius of curvature. Because it is a sphere and it has a center, so it has a radius. So the radius of a sphere that the mirror is part of it, we call it the radius of curvature. Number 3, the pool. The pool, it is the point in the middle of the reflecting surface of the mirror. Let's see picture to explain those definitions. This is the sphere, and this is a part of it which is the mirror. The center of curvature, it is the center of the mirror. Here in the concave and in the convex, both of them. But here in the concave mirror, the center in front of the mirror, because the inner side هو reflecting surface عندي. لكن هنا reflecting surface هو outer surface، لكن الجزء الجراي ده هو مش ال reflecting surface بتاعي. So here the center is behind the mirror. يبقى in concave mirror the center of curvature is in front of the mirror, but in convex mirror the center of curvature behind the mirror. Distance between center of curvature and pool, it is the radius of curvature. The pool, it is the point at the middle of the reflecting surface. Point في نص الكيرف كده اللي هو الميرور. Let's see the fourth definition. It is the principal axis. I'm sorry. The center of curvature, السيمبل بتاعه is C. Pool, the symbol is P. Principal axis, it is a straight line. It's not a distance, it is a straight line that passes through the center of curvature and the pool. So it is the line which passes by 2 points, which are center of curvature C and the pool P. Let's see. So this is the principal axis. We have only one line, one single line that passes by those 2 points, which is called principal axis. So each mirror contains only one principal axis. Let's see the rest of the definitions. We have also the secondary axis. The secondary axis is the line 2 that passes through the center of curvature and any point on the surface of the mirror except the pool. So the line that passes by the center of curvature and any other point except the pool is called secondary axis. So we can say that we have uncountable number of secondary axis, but we have only principal axis. The focus, if capital the focus is the point of collection or intersection of the reflected rays when these rays fall parallel to the principal axis. يبقى الفوكس هو البوينت اللي بيحصل فيها collection أو intersection لكل الرeflected rays. احنا اتفقنا إنه الميرورز بتعمل reflection لللايت. الانترسكشن بتاع كل الريفلكتد لايت ريز في one point دي بنسميها الفوكس. الفوكال لينث or f small it is the distance دي between which two points between the focus and the pole. Focal length equal half the radius of curvature. So, if the radius is 8 centimeters, so the focal length is 4 centimeters. And if the focal length is 4 centimeters, so the radius will be double this number and it is 8 centimeters. How to calculate the focal length of a concave mirror? Let's see the picture. Firstly, all those light rays, the reflection are intersected or collected in one point. This point is called the focus, as we have said before. We firstly use a source of light, comes from the sun for example or any other source of light, and then we adjust a screen to allow the reflected light to collect on it, and the distance between the screen and the pole of the mirror is the focal length. Let's say it again. The light comes from a source and then it's fall on the mirror and it is collected at a point which is called the focus. The distance between the focus and the pole of the mirror, it is the focal length of the concave mirror. Of image by the spherical mirrors, we will use 3 rules to determine the directions of the reflecting light rays incident on the concave mirror. We need, firstly, before studying the cases of formation of image through concave mirror, to know what will happen if a light ray fall on a concave mirror. The first case, when the light ray passes parallel to the principal axis of the mirror. As we see in this image, the light ray passing parallel to the principal axis. So, when the light ray falls on the mirror, it's reflected passing through the focus. The second rule, when the light ray passing through the focus, as we see here, the light ray will pass through the focus and fall on the mirror, and then it will reflected parallel to the principal axis. So we can summarize it by saying parallel, focus, and focus, parallel. The third rule, it says when the light ray passing through the center of curvature, the point C, the light ray will reflect on itself. Why the light ray which fall on the mirror passing through the C reflect on itself? Because it's fall on the mirror with an angle 90. And we said that when the light ray fall on the reflecting surface with angle 90, it will reflect on itself. Those are the three rules that we use to draw the different paths of light ray through the concave mirror. Let's talk about the path of light ray reflected from a concave mirror. Firstly, we need to know few things: position of the object, position of the image, what are the properties or characteristics of the image, and the draw of that case. احنا اتفقنا انه changing the position of the object will change the position of the image and the properties of the produced image. طيب احنا عندنا more than one case for the position of the object. Firstly, if the object at a distance larger than the radius of curvature. معنى انه الobject at a distance larger than the radius ان هو at a distance more than double focal length، لانه double focal length equal radius، او بمعنى تاني الobject after center of curvature. As we see here, the object after the center of curvature. We draw the mirror and then the principal axis, and we draw the radius of the mirror, and we put the points P, F and C, and then after the center of curvature, whatever the distance is, we draw the object. The object is drawn as an arrow, and from the object we draw two lines, one of them parallel to the principal axis and it will reflect passing through the focus, and the other will be, you have the choice to draw it passing through center of curvature and reflect on itself, or the easier way to draw it passing through the focus and reflect parallel to the principal axis. بعد ما نعمل ال two lines دول، الرeflection بتاع two lines will intersect in a point. ال point of intersection هي اللي هبدأ أرسم منها أو أعمل الدراوينج بتاع الإيمج بتاعتي. هنا ال intersection حصل between ال focus وال center of curvature. يبقى ال position of image between ال focus and the center of curvature. طيب هنا ال intersection بين ال two light rays الأساسيين كان at the head of the arrow. ال intersection هنا برضو هيبقى at the head of the arrow. طيب معنى كده انه هنا ال intersection كان upward، هنا ال intersection downward، يبقى معنى كده انه الامج هتظهر لي inverted، and any inverted image is a real image. So the properties او ال characteristics بتاعت الامج بتاعتي ان هي real, inverted, smaller than the object او بنسميها minimized او dimension. Second case, the object exactly at the center of curvature. واحنا بنرسم الكيس دي لازم نبقى حريصين جدا، لانه لو 1 ملي difference between الكالكوليشنز بتاعتنا مستحيل يطلع الايمج بتاعي برضه في نفس البليس، لانه دي الكيس الوحيده اللي الاوبجكت والايمج at the same position. الاوبجكت at the center of curvature عملنا منه two light rays، واحد parallel فرجع passing through الفوكس، والتاني كان passing through الفوكس and returned back after reflection parallel to the principal axis. الانترسكشن بتاعهم حصل exactly at the center، يبقى both الاوبجكت والايمج at the center of curvature. طيب ايه هي البروبرتيز بتاعت الايمج دي؟ بتكون دايما real, inverted and equal in size to the object or at the same size of the object. Third case, when the object between C and F, or it is at a distance less than the radius or at a distance less than double focal length or the object before the center of curvature. اما نعمل التو لاينز بتوعنا ونعمل الريفليكشن بتاعهم الانترسكشن هيجي دايما في الحالة دي after center of curvature، يعني at a distance larger than the radius أو at a distance larger than double الفوكال length. والإيمج عندي بما إن هي inverted يبقى it is real image and it is larger than the object أو magnified. في 3 cases اللي قلناهم نقدر نعمل summarize أو نلخص الكلام ده بجملة واحدة: after, before, after, at the center. after before معناها إنه when the object after center of curvature its image before center of curvature. before after معناها إنه when the object before center of curvature its image after the center of curvature. at the center it means when the object at the center of curvature its image also will be at the center of curvature. Case number 4: when the object between the focus and the pole F and P, when the object is here we draw 2 lines, one parallel and comes passing through the focus, reflection, its reflection passes the other, passing through the center of curvature and reflected on itself. And then the 2 lines are not intersected here, so we make an extension for the 2 light rays and the intersection will be behind the mirror. It is not in front of the mirror as all those cases. And it is upright. When the image is upright, it's called virtual. It means it can't be received on a screen. And it is magnified or larger than the object. In this case, when the light ray is at the focus, we draw 2 light rays. One of them parallel to the principal axis and reflected passing through the focus, and the other light ray passing through center of curvature. And we have studied before that when the light ray passes by the center of curvature it reflects on itself as the angle of incidence equal angle of reflection equal 0. As we see here, the 2 lines, the 2 reflected light rays are parallel to each other, and if we make an extension to the reflected light rays, the extension too will be parallel. So in this case no image is formed. Why? Because the reflected light rays and their extension are parallel to each other. And the last case is when the light comes from a very far object. When our object is very far or the object at infinity, the light rays comes parallel to each other, and as they are parallel they reflected passing through the focus and intersected at the focus, and so the image is formed at the focus and it is real and very tiny, it means dot. Let's see a video to explain the cases of mirror more.
The position and nature of image, formed by a concave mirror, depends upon the position of object. There may be 6 positions of the object. So, 2 points remember. The intersection of 2 reflected rays gives the position of image. The position, size and nature of image formed by concave mirror depends upon the position of object. First case. When the object is at infinity. The rays coming from the object, placed at infinity, are parallel to the principal axis, which passes through the focus after reflection. And the point, where 2 or more reflected rays meet, is called the focus. So, the image is formed at focus.
The 2 light rays here are
The position and nature of image, formed by a concave mirror, depends upon the position of object. There may be 6 positions of the object. So, 2 points remember. The intersection of 2 reflected rays gives the position of image. The position, size and nature of image formed by concave mirror depends upon the position of object. First case. When the object is at infinity. The rays coming from the object, placed at infinity, are parallel to the principal axis, which passes through the focus after reflection. And the point, where 2 or more reflected rays meet, is called the focus. So, the image is formed at focus. Since the image is formed by actual meeting of the reflected rays, thus the image formed is real. The size of image is much smaller than the object, so we say, the image is highly diminished. Second, when the object is placed beyond center of curvature. Here is an object AB, placed perpendicular to principal axis, beyond center of curvature. A ray of light from point A goes parallel to principal axis. This will pass through focus after reflection from the mirror. Another ray of light.
As we said that we have 2 light rays. One of them parallel to the principal axis and reflected passing through the focus, and the other passing through the focus and reflected passing parallel to the principal axis. And at the intersection of the 2 reflected light rays, there is our image.
Perpendicular to principal axis of the mirror. So, here's what we can say about image. The image is formed between focus and center of curvature of the mirror. The image is real and inverted. And it is smaller than the object, so we say the image is diminished. Third case, when the object is placed at center of curvature. So again we take an object AB placed perpendicular to principal axis, at the center of curvature. A ray of light from point A goes parallel to the principal axis. This will pass through focus after reflection from the mirror. Another ray of light we are taking is incident on the mirror, after passing through focus. This will be reflected parallel to the principal axis. The meeting point of 2 reflected rays will gives us the image of point A. We term it as A'. Now, we draw a perpendicular A', B' to the principal axis of the mirror. This is our required image. So, here's what we can say about image. The image is formed at center of curvature. The image is real and inverted. And it is of same size as the object.
When the object at the center, both object and image at the center of curvature.
Fourth case. When object is placed between center of curvature and focus. Now the same object, basically we are having here, AB, placed perpendicular to principal axis. A ray of light from point A goes parallel to the principal axis. This will pass through focus after reflection from the mirror. Another ray of light we are taking is incident on the mirror after passing through focus, as the case of previous. So this will pass, or say this will be reflected parallel to the principal axis. The meeting point of 2 reflected rays will give us the image of point A. We term it as A', and we draw a perpendicular A', B' to the principal axis of the mirror. So this is our image. So here's what we can say about image. The image is formed beyond center of curvature. The image is real and inverted. And the image is magnified. Fifth case. Now the same object is kept at focus. A ray of light parallel to principal axis will pass through focus after reflection.
شباب هنا في الكيس دي في حاجة محتاجة أكد عليها. أول ray بنرسمها parallel and then reflected passing through the focus. الأذر ray احنا مش بنرسمها بالطريقة اللي هم راسمينها دي. احنا بنرسمها passing through center of curvature and when it falls on the mirror it reflects on itself. احنا ما بنرسمش الray التانية دي بالشكل ده. بنرسم الray كده passing through الفوكس and fall on the mirror. last case دي when the object between الفوكس والبول برضو بنرسم التو rays بنفس الطريقة اللي رسمناها بيها في أول مرة. ما بنرسمش الري، بنرسم أول ري كده والري التانية بنرسمها parallel and then it reflected passing through the focus. مش بنرسم الري passing through the pole. المرسوم هنا ده مش ده اللي احنا اتعودنا عليه. احنا زي ما شفنا في الرسمة اللي احنا شفناها كنا بنرسم two light rays، واحد هنا passing through center of curvature والتاني parallel to the principal axis and then reflected passing through الفوكس. بس في الاخر الايمج بتطلع بنفس الطريقة اللي احنا متعودين عليها، بس احنا ما بنرسمش الريز زي الفيديو. الري بتاعت البول دي احنا مش بنرسمها، بأكد تاني.
And it is magnified.
Now let's see the uses of concave mirror. We use concave mirror in pocket torch, in front light of cars, and in shaving, and also in marine lighthouses that are found at marine ports and airports, as we see here, in aircrafts landing at airports, in solar ovens, by dentists, and in some type of telescopes. And now let's talk about the formation of image through a convex mirror. In convex mirror, whatever the position of the object, the image will form it with a properties which is smaller than the object, upright and virtual, and it's formed also behind the mirror. So whatever the position of object, the position of image is constant and the properties of image is constant. Now let's see the uses of convex mirror. We use the convex mirror as a side view mirror on the passenger side of a car. Why we specially use the convex mirror as a side view mirror? Because it forms an erect or upright and smaller image for the way behind the car, so it allows the passenger to see the way behind him when he drives. This is the side mirror. And the other uses at shopping centers, on the corners of narrow roads, at cars park, and the last one at the platforms of the metro and railway stations. All the uses of convex mirror, we use convex mirror in all these uses because it forms an erect or upright and smaller image for the area. So it allows us to see so much details for the place. Let's remember what's meant by real image. Real image, it is the image that can be formed on a screen, while the virtual image, it is the image that can't be formed on a screen. Let's read a small story. According to the Greek legend, that Archimedes, and he was a scientist, knew a lot about mirrors, and he used sunlight as a weapon against the Roman fleet that invaded Sicily in the year 212 BC. As we see here, Archimedes used a huge mirror and he put it by the way that the sunlight falls on it and the reflection of the light rays will collected at a point which is the focus, and the focus is at the sails of boats and ships. So he makes a great fire and they all burned, and so they destroy all the ships. By the ending of this story, we come to the end of our lesson today. Hope you enjoyed and hope you understand how to draw the path of light ray and to know what is the position of images formed by the concave mirror. And I hope to see you again in another lessons. Thank you and goodbye.